everybody's probably familiar with this quote. It's often quoted, but it's not usually quoted along with the next line that comes after it. Yet we should not pass up those opportunities in the critical 3%. And that's Donald Knuth.
In a book that was really titled "Structured Programming with Go-To Statements."
Yeah. No, it's not a book. It's a. You have to find the PDF of a scan of an article that he almost hand wrote. I think it's typed on a typewriter, so it goes back a few years.
Is this the origin of Go-To considered harmful as well?
Yeah, the same article. Yeah. Yeah. No, the response to Go-To considered harmful, right? I'm trying to remember. I thought it was Dijkstra that did Go-To considered harmful, and then Knuth responded.
Yeah,
so,
that sounds right.
Yeah. Okay, we're going to try to get an overview of XS, not the typical overview where people are explaining all the details, but explaining kind of the fabric that we're going to be working with XS. So what is XS? This is what Perl XS, the pod, has to say about it. XS is an interface description file format used to create an extension interface between Perl and C code or a C library, which one wishes to use with Perl. And we're probably somewhat familiar with examples of Perl XS. List util, for example, on CPAN is an XS module almost entirely now. And XS has somewhat of a reputation. So this is what PerlDoc says about it. Here's what Simon Cousins says about it. It's a complex and awkward intermediary language. Damian Conway, hooking Perl to C using XS requires you to write a shell.pm module to bootstrap an object file that has been compiled from C code, which was in turn generated by x sub pp from an XS source file containing pseudo C annotated with an XS interface description. If that sounds horribly complicated, then you have achieved an accurate understanding. So, and he's not far off on that. Actually, that's probably a better description than the PerlDoc one. It really gets all of the major points. Brian Ingerson, Ingy, there's a big fat learning curve involved with setting up an XS environment. And then my own quote, the cognitive load is high, which is counterindicated for producing cleanly implemented bug-free code. It seems like every line of XS code requires, no matter how much you've been doing it, I'm still fairly new to it, but no matter how much you've been doing it, it still requires research on almost every line of code that you write. And then still, you end up uploading something and the smoke testers come back with failures under other Perl versions that you didn't consider. And so, okay. This is the start of a conversation on Perl monks that goes back to the year 2000. And then he said, by the way, do you know C++? And I do, though I prefer to work in Perl. And he said, good, because these log files might be terabytes big, and in that case, we're going to need C++. To which Randall Schwartz responded, tell him you write a prototype in Perl, and if that turns out not to be fast enough, you'll recode the critical parts in C, thanks to Perl's sophisticated interlanguage binding and runtime profiling tools. Randall actually said that kind of tongue-in-cheek, and I've heard him say it a few times after that, because he always knows that most of the time you write it in Perl, you prototype it in Perl, and it never ends up getting rewritten in C because it works out just fine. But there is, as far as Knuth says, that critical 3%. Okay, let's look at the binary search. So here it is implemented in pure Perl. This is a stable binary search, so the first element in a list that matches will be the first one returned, versus an unstable binary search which would return, if you've got 3 elements, for example, that are all the same thing, it could return any one of those 3. Here we've prototyped in pure Perl. And one thing that I'd like to draw attention to is that the code itself is generic code, or written to be generic. The user passes in a code reference which specifies how to, that code reference becomes the comparator for C++ people. And so you end up being able to call this particular binary search the same way you would call a sort routine, where you specify A and then an operator, and then A CMP B, or A and then the spaceship operator B, for example. And so we've written a generic algorithm here that is made specific by passing in a code ref. That's a very good idea when it comes to excess code, I believe, because when you're writing excess code, the less you can actually touch and look at inside of Perl's internal data structures, the better off you are. If you can write the code in a generic way and then pass in an SV and pass in a list and pass in a comparator function from Perl, then you have done most of the work in Perl, but run the algorithm in C, and you're that much ahead. And so I wanted to show, let's back away from this for a second, and let's pull up the binary search algorithm in Perl, or in C.
What's the burger?
The what?
The little hamburger icon.
Oh, you know what? You can set up Google Chrome to allow different users, and if my wife is using it, then it shows like a handbag or something.
Okay.
And if I'm using it, it shows hamburger, and that way I know that I'm not getting her email or something.
That's cool.
Yeah. Okay, so let's look at the source code for the binary search. And we're just going to look real quick at the, can you guys see this okay? Here is the bin search. And you see that it's written, again, to be a generic algorithm. We're passing in a block of code. We're passing in the needle as a SV, which we'll get to in a minute. But an SV is a Perl scalar, essentially. And we're passing in an array reference containing a haystack that we're searching for. And down here, let's see, we're going to do push multi-call. This is basically setting up to call this block of code, and then we call that block of code as the comparator within our C function, within our C code here. Does that make sense, what we're doing? And so I'm not trying to show you all of how XS works. I'm trying to show you a strategy here of, if you can pass in a comparator and allow Perl to do the comparison and then run the rest of the algorithm in C without ever touching the data, then you're so much farther ahead, because you don't have to deal with dealing with Unicode. You don't have to deal with those sorts of internals. So let's see. We'll move on back to my slides again. No, we're going to have to do this. Sorry about that. Okay. So the XS rewrite was what I just showed you there. But writing XS code by hand is a big pain, and one of the shortest paths to actually getting there is using Inline C to start with, and then you can Inline C creates the XS code for you, and then you can paste it into a module if you want. And so what is Inline C? Inge, who's the author of Inline C, he got fed up writing XS. Inline C creates the XS code for you, and you don't really need to know or care how. You can embed C code in your Perl program and let Inline C translate that to XS for you. Inline C creates the XS bindings for you. On the first time you run the program, your Perl program with XS code in it, or with C code in it, it compiles the source code, and then subsequent runs use a cached copy of that XS code. If you embed Inline C in a module, then when the module is first installed, the XS code is produced, and it never has to be produced again. So here's an example of using Inline C. Now we're looking at, this is Perl code. There's no shebang line, but use Inline C. We've got a here doc here. Now this is C right here. All right, people recognize that. Now we're calling it in Perl right here. This is Perl here. You got it? It's pretty simple to start out with. What happens behind the scenes is another story. Now here's another simple example. Here's a one-liner. Perl-E. We've got a one-liner here. Use inline C, quote void greet. We're now in C, now we're in Perl here, calling the greet subroutine, and you'll get your greeting. Because, as it says in the Inline C pod, a concept is only in valid Perl if it can be shown to work on one line. What does that look like in XS? So this is the output that it creates. It creates an XS file. It includes some Perl-related headers. Here's the subroutine itself. It names a dummy module called E101C. That's going to always be different. It uses a hashing algorithm to create this little module name. It puts it into package main for you. Disables prototypes. This is XS metadata here for how to handle the bindings, the transitions. And then this is the code that's used to call our little void greet whatever. So that's what it looks like in XS. That's what Inline C did for us. Okay, another way to use Inline C instead of using a here doc is to create a data segment, and under the data segment create a C segment, 2 underscores C, 2 more underscores, and then put your C code down at the bottom of your script. You can put it at the bottom of the script, or you can put it at the bottom of a module. So.
Could you go back?
Yeah.
To that screen? I take it that sorry, I need to point.
Yeah, go ahead.
This is actually going to be handed to a C compiler at some point.
Yeah, what actually
This
happens...
is going to be compiled to the glue code that Perl calls.
Yep. Yeah, what actually happens... No, that's a good question. The XS... This is an XS file, right? And then XSPP, or maybe xutils makemaker, one of these guys ends up invoking the C compiler and compiles portions of this and saves portions of it for the binding. But when you're writing XS code, you don't write C directly. You write in this crazy glue language, which is kind of a mess. And that's where Inline C is so convenient, because it allows you to just write in C again and not have to deal with writing in the XS to begin with. There are some things that you really have to kind of get into the internals for, but that's a good start.
But there are 2 things named greet there. It looks like
and so let me show you what that is. So this is the actual subroutines. This is going to become the C code. And then this is the binding for it here. This is pre-init is setting up some temporary variables that are necessary for the bindings. This is telling Perl that we have a subroutine called void. That has a void return value that's called greet. It finds the bindings go ahead and find this one to link to, and then all of this is the glue code. Actually, what's happening here, if I can remember how to read it. This is dealing with setting up the Perl stack, which we'll get to in a minute. The call stack, the call stack pointer. This is just the glue code that kind of wraps around your C function to make it callable from within Perl. And so here we've just got the C code at the bottom of our Perl file under a C segment. Basic data types can be passed back and forth automatically from C functions. And so in this case, our C function returns an integer and accepts 2 integers as input, and just returns just adds them together. And then we're calling it from Perl right here, add apples and oranges. And so, and the reason that this can happen is because there's a file on your system called typemap, and it's supplied by xutils makemaker, I think, or it might be xutils x sub pp, or one of those modules that comes as part of the Perl core. And the typemap file contains translations between Perl data types and C data types, and those translations are in XS glue code. So here we're passing a string, and we're ignoring Unicode because this string is just using char pointer. But again, you can return a string. That has a bug. Right? I'm returning an automatic.
Yeah, that's
Yeah.
very interesting.
Yeah, that's a bug in the C code. Returning an automatic array or an automatic pointer to automatic storage space would result in a null pointer or an undefined pointer when you get out of there. Okay, it's not going to stay easy forever. If your data type isn't in the type map file, then you've got to create your own type map, or you have to just revert to dealing with SVs, with Perl scalars and decoding them inside of your C code. If you try to pass a type that isn't automatically converted in the type map and you're not supplying your own custom type map file, then Inline C will just ignore that subroutine and won't try to bind it. Yeah.
What happens if the Perl code provides the wrong type?
So,
I mean,
In our previous example, you passed ins, but what if you hadn't?
what if you pass the string there? If you initialize apples as the string.
okay, yeah. You know, actually, that's handled by XS automatically. It's kind of nice. It's not even Inline C that's handling it for you. It'll tell you not a valid parameter type or something like that. It will die. It's a runtime die though. It's not a compile time, unfortunately, because Perl's data types are runtime. So
That's what I wanted to find out.
yeah. But it is a die with a message. It's not just, you don't just run off the end of a stack somewhere and have a blue screen of death. Okay, so I've been talking about SVs a couple times, and Perl's internals use something called a SV for scalar values, a AV data type for array values, an HV data type for hashes. Inside of, and AVs and HVs are just containers for SVs, for pointers to scalar values. Inside of SVs, you have pointers to integer values, unsigned UVs, unsigned ints. NV is for doubles, PVs is a pointer to a string. CV could be a pointer to a code ref. RV is a pointer to another SV, reference to a reference, I guess. All of these are kind of auto-vivified by Perl, vivified by Perl as needed. If you have a scalar that only contains an integer and then you suddenly use it for a string, then the PV gets created automatically by Perl's internals. But this is kind of your structure. You have an SV, and inside the SV you can have any of these types, one or more of any of those types. Some variables are even dual. What do you call it? Dual varled, dual typed. Yeah, like the bang, the one that you get from die, what do you?
Dollar bang.
Yeah, dollar bang. There you go, dollar bang, which contains an integer value and a PV, and they're not the same thing. The integer value will be your error code, and the PV will be a description of the error, and they're completely different. Okay, so there are 4 calling scenarios. If you kind of think through how things work, the simplest one actually is a set number of parameters, a known number of parameters, and a return value, a return type, all of which have type maps available for them. That's the simple case. All arguments and a single return value are specified in the type map, so you just write your pretty little C subroutine and life is good. Your C subroutine will bind to Perl XS and you're running C within Perl. The next scenario is a little bit more difficult. You're going to return a list, or you're going to return nothing, and you have a fixed parameter list. Now, to return a list, then you have to start dealing with, quote, the Perl stack. When you make a function call in Perl, Perl sets up a call stack, and on that call stack, it pushes all of the arguments that are all of the parameters for the Perl function, and then the return values from within the function. The return values get pushed onto the same stack, and that's your return value. The stack pointer is reset to the top. The return values get pushed on. Stack pointer comes back down to the end of the stack there, and and that's your return values. So if you're returning a list, you've got to use the Perl stack and push your arguments onto that list. And if you want to return nothing, you also have to use the stack. Does anybody have any questions? No? Okay. Now the next scenario is a variable length parameter list and a simple return. Variable length parameter lists in C and in C++, they're not that easy to work with. They're possible and they exist, but Perl, it's just a normal way of doing business. You don't know how long the parameter list is going to be, and so here we're passing. When you do a variable length parameter list, you always have to specify in your C function what the first argument is, and after that you just put the ... But inside the function, you've got to pop them off the stack yourself. You've got to read them off the Perl stack yourself. And then the most difficult one is a variable length return and a variable length parameter list. And in that case, you have to pop the parameters off the stack, reset the stack, push the return values onto the stack, and then you can return. So, yeah.
And when you write a var-args function in C, there's no way to find out how many arguments were really passed. I'm guessing that's not true with XS.
That's correct. Yeah, with XS, in fact, I can show you probably next, or coming. I'll show you in a minute. Yeah. So okay, here's an example of the first scenario. This is what your code's going to look like. You tell it that you're returning an int and that you accept an int. We've already seen one of those. It's pretty simple. The second scenario. Before we can discuss the rest of the scenarios, we have to talk about the stack a little. Inline C gives you these nice little macros, which each of these macros expand out to a whole bunch of other XS macros that you don't want to know about, unless you really want to, but you don't want to. They're a pain. So inline stack vars essentially sets up your subroutine's ability to access the Perl stack. Inline stack items tells how many items are on the stack. There you go. The inline stack item I here lets you read one item off the stack. Inline stack reset resets the stack pointer again so that you can start pushing things onto it. Inline stack push starts pushing return values onto the stack. Done tells Perl that you're done using the stack. I forgot what inline stack return does. I forgot. And inline stack void tells Perl that you're not returning anything if you have a function that doesn't have a return value. Examples are probably better. So here's an example of the second scenario. So here we have let's see, what are we doing on this? We're returning void, but we have several arguments, and so we're going to tell Perl to tell Inline C to set up the stack for us, reset the stack, and then to iterate through the stack. Oh no, I'm sorry. Here we're returning more than one item. You're going to push your items onto the stack, tell Perl you're done with it, and now you can go ahead and exit out of your subroutine, and those items will be returned from this function.
I take it those macros created new SVID.
Yeah. Yeah. Let's see here. Okay, here's the third scenario. A variable length argument list returning a single basic type. So you always have to have at least one parameter on a. When you use variable length argument lists in C, you always have to have at least the first parameter as a named parameter. After that, you can have your. This is just C syntax here. It has to be done that way. But you're still going to set up the stack, and now we're going to iterate. As long as I is less than the number of items on the stack, then we can print. Here we're going to go ahead and print the string that's contained within the individual arguments of this that are called on this function. So this function, for example, if it were called with a list of 10 names, 10 strings with people's names, then it would just iterate through the elements in those parameters and print those 10 names.
I got a quick question.
Yeah.
On the previous example, you had void for the return value.
Yeah. That's because we're not returning something from the C function. We're pushing.
Just on the stack.
Yeah, we're just pushing it on the Perl stack. Yeah, good question. And the reason that this one, for example, is returning an int is because this one is relying on Perl's own built-in type maps to go ahead and return it. And behind the scenes, it's doing all this stack work for us because it's what you would consider a simple case that Perl can do automatically for us, or Inline C can. So that's the third scenario. And then the third scenario, part 2, variable length argument list and a function that returns nothing. So here we're reading through our incoming arguments, and then we have to tell Perl that we want to return nothing from this function, explicitly specify no return value. And then here's the fourth scenario, variable length argument list to return multiple values. And I don't think I provided code on that because we've gone through all of the other things, and you can just you combine you combine step 2 and step 3 essentially. So now it's no longer difficult, right? It's beautiful, but it's still ugly because it's C and it's Perl and it's internals. So a lot of ugliness going on here. Some strategies that I've found that work out well. It's often easier to write generic algorithms, as I mentioned before, that don't care what Perl's SVs contain. And that's really something that I kind of learned from C++ with what they call the standard library, where you pass in, where the standard library can hold any type of data basically, and then you pass in comparators, which are callback functions that can handle comparisons. And that is essentially C++'s way of getting at generic programming, that and templates, but those are templates. In Perl, we take for granted that we don't have to worry about generic programming too much, but when you start thinking in terms of how do I make a C algorithm that can work with Perl, you really have to kind of think in terms of generic programming, passing in the SV and not caring what the SV contains, and then separating out the code that's going to actually do something with it. Whether you can let the user supply that code or whether you write it as a separate subroutine, whatever, just to make it easier to manage separation of concerns, I guess. Now we're going to take a little tangent. Does anybody know what Duff's device is? Okay, you guys have heard of it, yeah. And so this is an unrolled loop here, Duff's device. Duff's device is you take a loop here, and that loop takes some time to execute. And so instead, we're going to unroll it. So it's only looping once for every 8 or once for every 7 items that it deals with. Yeah, it's a optimization. And Tom Duff, he said, if your code is too slow, you must make it faster. If no better algorithm is available, you must trim cycles. And using XS and using Inline C, it's really about trimming cycles because you don't want to get into it unless you absolutely are already using the best possible algorithm in Perl, and even then it's still not fast enough. Then it's time to start messing around with XS because something that would take a coder 5 minutes in Perl is going to take them a day or 2 in XS to get it right. At least in my case. The sieve of Eratosthenes. Anybody that's been to CS school has probably dealt with the sieve of Eratosthenes at some point. This is one of the fast ways of generating prime numbers. So here it is in pure Perl. Here it is, the same algorithm using Inline C. And so we're passing in an integer that tells how high we want to search to. We're going to return just a scalar value, just because Perl knows how to deal with it. It's easier that way. An AV, we're setting up an array within our C code. We have a pointer to booleans of primes, and then we go through the sieve. And the way the sieve works is you've got a big sieve of ones and zeros, essentially. It starts out all zeros or all ones, and every time you find a number that cannot possibly be prime, then you flip the bit from 1 to 0. And here we're using bools. And then in the case that I did here, I'm just returning an array. I'm pushing a bunch of items onto an array that will be the primes that we found in this sieve, and we're now returning the array. So there's our prime sieve in C. And just for fun, I did it also in C++, but I think there's probably not a whole lot of difference, except that I'm using a standard vector bool, which is a broken container, but it works just fine in this case. And so now we're taking up a little bit less space for our sieve. We can get a larger sieve because we're using booleans instead of integers for our sieve. And again, we're just returning an array, a reference to an array that contains all of the prime numbers up to and including whatever our, what's our call? Up to and including our high water mark that we've requested.
So obviously, there's memory allocation occurring in here in C that is being provided backwards to Perl.
Yes, and what I'm
That's
doing
what
here,
pushes are?
yeah, there's two things that work. Now the vector is we stop using the vector. We set up the vector. Where is it? Okay, right here, we're creating a new AV. Perl's allocating the space for the array, and then now we're setting up a vector bool. But this is automatic, so this one's going to go away.
Yeah, that's the C one. It's
Yeah.
going to go away. You're not setting it back.
Yeah, that's going to go away, so I don't have to worry about garbage collection for that one. And then down here, here's where it gets a little bit complicated, because now I'm going to push my answers onto this Perl array. So I'm creating new, here's the number 2, and here I'm going to create 3, 5, 7, and so on. But these are new scalars that we're creating. Those new scalars get pushed into our Perl array. Each one of these is a little new allocation, supposedly. But Perl handles this. This is a macro, and Perl handles the allocation and knows about it at this point. And now we're returning the scalar, the array reference, and we're telling Perl here, don't increment the container's reference count. We know that Perl's a reference counted garbage collection language. We're telling Perl, we're telling Perl, don't increment the reference count, because what ends up happening is that the return value on the Perl side, the caller takes responsibility for the reference count. If this function actually incremented the reference count, then the reference count after the call was over would be 2. You don't want that. You want it to be 1, so that when the caller falls out of scope, then the array is destroyed. So that's avoiding a memory leak there. And this is what I mean about XS being a real pain, because you have to be very careful about memory leaks at every point, and about all these little things, and the error messages are just awful.
So if you took a parameter of another SV and you were to return that SV in an array, you would have to increment the
reference count?
Reference count and things like that.
Yeah, now this,
we're not doing that here.
Yeah, right.
But you have to manage those manually.
Yeah, you do. Now there are macros that will automatically, some of the macros to create SVs and AVs and things will increment the reference count, and then there are versions or flavors that do not increment the reference count. So you have to be mindful of which of those macros to use. And also, this transition right here, as you're returning, is always the most critical one, because it's really easy to forget. There's even a macro called SV to mortal, which decrements the reference count after the return executes. And sometimes you have to use that to keep from getting a memory leak. So off to the races. We're doing this because we want speed, right? We're going to benchmark just finding 2 primes and then finding all of the primes in the first million integers. And the C versions can find 3 million primes in less than a 20th of a second. The C version tested up to 650 million primes after that, because I was using an integer sieve. I ran out of memory. The C++ version, I've actually used up to, I think, 4 billion on a 64-bit machine without running out of memory, and it does it before you can finish a glass of water. So here are some benchmark results. So again, we're looking for the first, was it million that I was doing? The first million primes. We're going to test for 10 seconds, and we're only looking, actually the first one we're only looking for the first 2 primes, okay? Or all of the primes between 1 and 2. We know there's only 1. So this is kind of a test case, or a control case. Pure Perl can do 400,000 executions a second, pure Inline C 820,000 a second, and Inline C++ 881 cycles a second. Now we're going to lay it on here. We're going to do, this is 1 million. Is that 1 million? 1, 2, 3, 4, 5, 6. Yeah, 1 million. We're going to find all of the primes between 1 and a million. Pure Perl can only do 1.48 iterations per second. Inline C++ 61 per second, and Inline C did it in 73 iterations per second. So it's significantly faster, 4,800% faster. But it's not all about speed. Unit testing of C code and libraries is another cool thing. I was actually doing some work in C++ where the people didn't have a testing framework that they were using, and I ended up using Inline C++ as a means of exposing the C++ internals to my Perl test suites, or to my Perl test harness, the tap harness, test more, and so on. Also extending Perl's interface to its internals, like scalar util. A lot of those things like looks like number, scalar util, dual var, some of those have to get into XS to do what they do. And then building on the strengths of each language in complex ways, extending Perl with C and XS, or embedding Perl in C. All these things are fun. Okay, here's an example from Perl Testing a Developer's Notebook. That's a book by Chromatic and Ian Langworth. So here they're using Inline C. Inline C has a feature where you can give it a header file for a C library, and it will automatically wrap each of those functions in XS code for you. You don't have to really write anything. There's no C here, right? Now we're going to import. We're going to just import the functions that we want to test, and now we're just going to use test more to test our C functions, right there. We gain the ability to do rapid test prototyping using Perl strengths, and we're testing C code. So you saw the Autowrap right there, and that's something that is used quite often. I think it's even being used in the development right now of Boost Graph, in the development of the Perl module of Boost Graph. Boost is a C++ set of libraries, and Boost Graph is a graph algorithm, shortest path, some of the nice Dijkstra algorithms. There's a Perl version of it which uses the C++ library and then auto-wraps it using Inline C++ and exposes it to CPAN. Here's an example of linking to an external library. This one they're not auto-wrapping, but they're telling Inline C to use this library, this C library, and then it's going through and it's basically going through and importing the functions from that library that you want to use in Perl. And that's how Perl TK works. They probably didn't use Inline C to do it, but they may have used it to develop it, but at least Perl TK and some of those WX widgets for Perl, some of those modules basically are wrapping external C libraries in XS.
Most C libraries have structures and things like that in them.
Yeah.
And typically you want to have those structures be passed around. They'll be opaque within Perl, but they can be passed back to the C function, which would then do something with it.
Yeah.
I haven't seen anything like that here. Is there a way to have that opaque object in Perl?
There is. And actually Inline C++ does it fairly well. Yeah. If you have to do it in C, then you can do it. You can create type maps for your structures and pass the structures back and forth, no problem. So here's an example of using Autowrap. I just threw that in there. can automatically generate the function wrappers to link functions in a library with Perl. Okay, so you can take advantage of a lot of Perl's power tools from within your C functions. You can call Perl code from within your C functions, and so you can execute code refs. You can create lexical blocks in your C functions, lexical Perl blocks in your C functions, so that you can do currying, you can do closures. All of that sort of thing is available from within your C functions by using Perl's tools.
I have a quick question for you.
Yeah.
So with the wrapping,
Yeah.
do you have any problems with leaks because of just using that technique, or
Yeah, you have to be.
you have to,
Sometimes, depending on the library, but some libraries you do have to go in. That's one of the things they're working on Boost Graph right now. Is after auto wrapping, now they're going through and finding areas where things are being created that aren't being dismissed properly, and there are some of those, but they can be cleaned up. It just takes some, that kind of thing takes some manual cleanup after you've got the main part of the code already put together for you. So, in Inline C++, C++ objects become Perl objects, and if they have private data, that private data stays private. It's opaque to Perl. But all of their methods, all of their public methods become exposed to Perl as Perl functions, or as Perl object methods. And so here's an object with Inline C++. I wrote this like a year ago, and so hopefully it's, I don't know. But here we're just creating a function for no reason. But here's your class, your public, your constructor, your destructor. Here's an accessor, and here's a setter, a getter and a setter, and then your private. You've got some private data. Now the way Perl sees that, when you run that through Inline C++, what Perl sees is, this is how you would write the same thing in Perl essentially: package main foo, sub new, sub destroy, sub get data, sub set data, and so. This is kind of an example of what that would be in Perl. Oh, and I didn't show what it actually looks like. Actually, what it looks like to Perl essentially is just basically that you have these functions available. You have get data available, you have set data available, but they're being provided by C++ and bound via XS. How do you distribute code that was written with Inline C? There's three ways. One is to create in your module an Inline C dependency. That is, I actually created math prime fast sieve, the module, as a proof of concept that it's possible and that it works. And so if you were to install this module on CPAN, it would pull in Inline C++, and it would compile the XS code for you. And so Inline C++ is a dependency of this module. Another way is a guy named Rob, I forgot his last name. He's the maintainer now for Inline C. He created Inline X C to XS and also Inline X C++ to XS. These are two modules that will take the guts that Inline C creates in XS and plop them into a XS module framework. And then you've removed your Inline C dependency. And in some cases, the simplest way is to simply copy the XS code that Inline C creates and plop it into the framework yourself. And that's what I did when I created list binary search XS, just as an example of how to do that approach. I basically wrote the module as much as possible in Inline C, plopped that code into an XS framework, and then did some more tweaking just for performance issues. So, how to make a module with an Inline C dependency. You start out with the old-fashioned Perl way of creating a module before module starter came along and some of those others. You're going to modify the PM file that this command creates. You're going to tell it to use exporter, use strict, use Inline C. That part doesn't have a whole lot of changes, but what you do have to change is in your make file. You have to change use xutils makemaker to instead use inline makemaker. that might, if you've put modules on CPAN before, you might be thinking, well, how am I going to communicate to the CPAN installers that we're not using XTUtils MakeMaker? In the metadata's configure requires section inside your make file, you have to tell it that inline MakeMaker is needed. And then the CPAN installers will pull that in automatically. There are people that love to help. The inline mailing list and the Perl XS mailing list are both very helpful. Other inline attractions. So Inline C++, I took over maintenance on that in November of 11, and it was only passing about 10% of the smoke testers. It was broken on Mac, it was broken on Windows, it was broken on many Linux distributions. Now we've got it to the point that it's passing about 90%, and we still have some challenges that we haven't figured out. It's hard to get good information back from the smoke testers when you've got so many moving parts. It's not just Perl that could be breaking, and you don't know what their environment is. Is the problem simply that they don't have G++ installed? It's hard to get at the bottom of what some of the problems are. But we got it up to about 90% pass ratio on the smoke testers. Inline Python actually works fairly well. There's a guy that uses it every day at his company, and he's on the inline mailing list, and he maintains it, and it seems to work really well. And there's one called CPR, and Brian Ingy says, the best compliment I've gotten for CPR is when my active state coworker Adam Turoff said, I feel like my head has just been wrapped around a brick. What the inline CPR does is it allows you to run Perl from within C. But using, look, it's dynamic. You got the shebang line there. Perl is invoked. Somehow it discovers that this call in your C program is calling Perl, and then it compiles the rest as C. Big mess, but it works. And that's just for fun. We're not going to explore that. So why C, why inline C, why XS? The real reasons for using XS, Inline C is to expose C libraries to Perl, getting closer to the metal, application extensions that have a bottleneck where no better algorithm exists, and unit testing. Usually you see XS being used simply for its speed. Often the first two other things are used as well. By getting close to the metal, I mean being able to expose, being able to gain access to some of the details of the operating system that Perl doesn't have access to, or some of the details of the hardware that Perl doesn't have access to natively, or also bringing in libraries from C. You can sometimes write faster code in C, but you can always write code faster in Perl. Since you can use each of them from the other, just combine the strengths as you see fit until the dragons we set high. And that's a quote from Programming Perl. Here are some resources, and I'll leave that on. That's what I've got. That's my presentation. Does anybody have any questions?
So Inline C's been around for quite a while.
It has, yeah. Ingy wrote it back in about 2000, and then he gave away maintenance a few years ago. Neil Watkus did Inline C++ in 01 or 02, and then stopped maintaining it. And I discovered it and kind of thought it looked interesting, and I submitted a bug patch on it, and then he says, hey, do you want to maintain it? So now it's mine. So, yeah, they've been around for quite a while. I believe that probably many of the XS modules on CPAN started out kind of in a proof of concept stage through Inline C++ or Inline C, and then got converted to pure XS to remove the inline dependency. So,
you mentioned that you have to be careful about memory leaks and things like that. Are
yeah.
there tools and techniques to find out that you've got them and where?
Valgrind. You got to get into the
Okay.
run a billion iterations and and measure the memory. That's about it.
In one word.
Yeah. Valgrind is a C-based utility that measures your memory consumption. Yeah. That's there's that, or of course, there's Silent Death, where you run it and all of a sudden it just crashes.
That's not a tool that helps.
No, that's not a tool. It's a yeah. At least you know you've got a problem. But and actually,
That's not a coat smell.
No.
It's silent but deadly.
yes, I am a deadly. And also, I really can't say enough for the CPAN testers, because when you create an excess module, the only thing that you're guaranteed of working is on your system, you know. And the CPAN testers can put it through dozens of different architectures and dozens of different Perl versions, and you're always going to find that Perl 5.8.1 didn't have some macro that was later introduced that you didn't realize is a newer macro in excess, or that it worked differently back then. And then you start digging into existing CPAN modules and core modules and finding what the workarounds are. Like a lot of in list binary search, I had to find how to work around some issues in Perl 5.8. And so you look at list more utils, because you think, well, that has a similar user interface and is doing some of the similar things to list binary search. So you start digging in prior art and looking at how other people have handled problems, and you can learn a lot that way. So that's it. Thanks for coming.